Good morning. My name is Jeliud. I'm now a association professor at the Institute of Software, Chinese Academy of Science. I'm very pleased to here to present my co-first author paper, PinchList. This is a collaborative work among the University of Manitoba, UBC Okanagan, University of Toronto, University of the Waterloo, and my institute. List view is the most common UI component for the content presentation on mobile phones, where the items are arranged vertically to support homogeneous data, browsing and reading. Many applications today are used list views, and in many cases, they follow hierarchical organization to present multi-view structure information. We have seen two type list view organizations, one with page transitions, and the other one with the view expand and collapse. I believe this is familiar to everybody in this room, and there is nothing special here. However, the problem happens when we are not familiar with the list structures, such as you file documents in this file manager application, or when we need to repeatedly view a list comment, such as to compare details to book flights. In this case, you probably had to go through several up and down in the hierarchy. Use tap and swipe gesture. Use tap and swipe gestures. This is somehow inefficient and tedious for users. Our solution is leveraging pinch gestures rather than the tap and swipe gestures to work on the list views and support quickly and easy viewed transition on the mobile phones. We call it as PinchList. PinchList work like this. A user start exploring a list by touching the screen with the two fingers pinched together. Invisible light cursor is activated in the middle of the fingers and consequently highlights an item located underneath it. Pinch out the fingers will split current views and reveal the window containing the item's trial list. The user's explorations the list by moving the finger up and down. The user may also quickly switch the different trial lists by pinch in to close the current views and move the fingers to another item. And pinch out the items to open the new trial list. We call this type of exploration as pinch and hold, which works with typical two-layer structures. If a list has more than two layers, pinch and flick operations are used to switch the views. Especially, instead of holding the fingers, the user performs a flick gestures, which move the top layer edge and promote the trial layers to be front view. The user may perform pinch and hold on the current layer. To resume the previous layer, the user made a flick or pinch in gestures with multi-fingers. We add features here to let the numbers of operating fingers identifies the number of the layer to resume. For example, 2 fingers resume 1 layer, and 3 fingers resume 2. And here is a quick demo to show how PinchList works on the mobile phones. Besides promoting a design idea, we perform 2 user studies to better understand the PinchList design factors and performance. In the first study, we explored the suitable design parameter for the PinchList. In the first study, we explored the suitable design parameters for PinchList. PinchList uses door fingers with the line metaphor to select in the list. Prior similar works exist, but they were neither designed for list navigation or not formally evaluated. We assume that the item size could be similar than conventional requirements, as the items are selected by a light cursor instead of a finger. And users' performance will be affected by the visibility of the item. Study 1 used the 1D fixed lot task to investigate how the target size and target distance affect the target acquisition using the PinchList. Under both scoring and no scoring conditions, a dwell time of 0.5 seconds was used to confirm the selection. Use the 3 techniques. With pinch int, a user requires a target with the thumb and index fingers. Pinch int. Pinch out is familiar to the pinch int, whereas the 2 fingers are kept apart and a distance of user's choice. Use the stand on the screen technique as a baseline. We also use the 5 target size to simulate different on the screen content size and 6 distance to the place targets on the screen and off the screen. The result showed that the tap was faster than the 2 pinch gestures for both static and dynamic conditions. The pinch in and pinch out conditions are include the dwell time to not introduce the potential bias in our analysis. However, the dwell was just experiments artifacts, not necessarily the selection mechanism for the PinchList. Additionally, we note that the pinch in and pinch out required to show the finger movement in order to prepare to store in the place. From the result, we can see that for pinch in and pinch out, average travel time increased largely when the target size was smaller than 6 millimeters. This is smaller than regular guidelines of the list viewed on the mobile phones, which is 8 to 10 millimeters. We also found that the target selections with the pinch in and pinch out can be modeled with this lot. Study 2 aims to evaluate the performance of the PinchList. Gesture in assessing items in a hierarchical list. To mimic real usage scenario, an analytic decision-making task was decided, asked users to explore and compare fruit price in different markets on different days, and find the minimum price. Here's a video to show the PinchList for the study 2 task. Besides of the PinchList gesture, we implement an expand and collapse view. This is a video. And the view switch list interface as the baseline. Two types of tasks are set. One task asks the participant to type 1, find the lowest price of a fruit in the market on X days. And the other task, a user to type 2 to find the lowest price of the fruit in the X market on a date. Another factor, target complexity, define the values of X in task type. Here, in these studies, we set X to 1, 3, or 5, which means in a trial, participants need to compare 1, 3, or 5 price before they can find the lowest one. The results revealed that PinchList was significantly faster than the wheel switch and expand and collapse. We found that With the PinchList, the participants perform more flick gestures on type 1 tasks. The frequent switch between the pinch and flick gestures made the task complete time longer. We decided 3 scenarios to demonstrate the benefits of using PinchList. The first one is PinchList supports the user to drag and move items across different folders. A user first selects a song with the pinch out gesture and force press to lock down and open the different folders to release the fingers, which drop the items into a new category. PinchList supports quick multiple selection with sub-view menus. In the shopping app, a user can use the pinch in and pinch out force press gestures to quickly purge books under different categories. PinchList supports command invocation and value selection in a single actions. In the setting, upon making a selection of the volume option, a user can adjust the volume from the sub-view with the finger moved up and down. There are many plans to improve the PinchList in the future work. We plan to look into the several key design challenges. First, the screen edge. It becomes difficult for users to move the fingers when the item is located close to the top or button. Screen edges, especially when use the pinch out gesture. One solution could be extend the length of the list, such as that the list always scrolling when the user move the finger up and down, and they do not need to reach the screen edges to acquire the items. Users' pinch fingers movements may sometimes scroll the parent list positions when the users pinch in and return to the previous layout. Designers should be careful on the possible wheel displacement, which may cause the confusion to the users. Although the users are familiar with the pinch gestures, applying them to operate list views is still new. We found that the study participants spend more time to get used to the PinchList gesture. In addition, new users may not know such gestures are available. This problem can be solved by providing sufficient tutorials and visual cues. To conclude, we presented PinchList, a new way to use the pinch gesture for navigating lists on mobile US. We show that PinchList performs better than with two standard list interface, view switch and expand and collapse. In tasks that involve browsing multi-items before reaching a decision in a list hierarchy. Thank you very much for your patient listening. Now I would like to be open to a floor for the questions. Thank you.
Okay, hi everyone. So if you have any questions, please raise your hand. There's SVs going around with the microphone. Can I remind that you mention your name and your affiliation, and also wave so that the speaker knows where you are in the audience?
Hi, I'm Mingming Zhang from University of Washington. Thanks for your presentation. So in your task, it seems like your pinch is limited in a short range when the items are very near to each other. It's handy. But have you considered when you want to navigate through a long list, and because the pinch is a continuous gesture, you have no fine control, or it might move slow if you want to move to a long range target, while if you are using scroll, you can stop and to fine turn the target you want. How it performs, or do you have any consideration about long range target selection?
These are good questions. This situation, we have think about it. If the list is very long, how can we use the window? Because we pinch out to split the windows, and we control the windows up and down. If we touch the edge of the screen, we cannot see the list below it. So we decided some method to solve this problem, but we don't evaluate it in this paper. Some good solution is that when we move the windows, the second layers is scrolled across in the Windows position. If we use the form just like this, the form's top edge, the form's bottom edges, this is a fixed length. So we can use the Windows position it in this place, and when we move down, the second layers will scroll. The scroll speed is decided by the length of the screen, and the second layers the length is a scale by the scroll speed.
Hi, this is Junhyeok from Stony Brook University, and thank you for your great work. And I have a quick question. So right now, like list view is kind of like hybrided. So in your PinchList movement, do you like consider that the like nesting instead of just like vertical listing item? Have you considered to like extend your PinchList to navigate it like horizontal list view or something like that?
Have you considered horizontal lists rather than just vertical lists? horizontal. Yeah. This is another good question. PinchList is just now suited for the vertical direct directions moving. If we use the horizontal directions, maybe we can use the gestures just like this. If we move the pinch up and down, and we can use the horizontal gestures to do more things, just like this. When we swipe to the left, we can perform the copy actions. In another conditions, if you say that we had grid view, this is a list, then this is another list. So the PinchList must divide the cursor into two cursor. So we can use the PinchList to perform the left list, and then we move to another areas of the right list. Then we control the right list. So we assumed used these two methods to do the horizontal direction gestures. Yeah, thank you.
So we have one more. We have time for one more question. Is there anyone in the audience that still has something? We've got a microphone at the front. Okay, I've got a question then. So, yeah. So, have you considered like the accessibility implications of this system? So it requires a lot of fine motor movement. So for someone that might have a motor impairment, is there a way, have you considered like redesigning this slightly to be usable by a larger group of people? Yeah, so like, for people with like, say Parkinson's or something like that, and they maybe can't do these fine motor movements that are required to use PinchList, have you considered any future iterations that can compensate for that?
The future works.
We can talk about this offline, maybe. I think Yeah, okay, we'll chat a little bit more later. So let's thank our speaker. And